Welcome to Vansik Maths. Today we look at how to derive the reduction formula in for this kind of function, the integral from 0 to pi over 2 radian sine raised by n x dx. How do you derive the reduction formula of this kind of function before we solve it? So remember to subscribe. So we know you're going to use integration by parts formula, whereby if you have u dv, it will give you uv minus the integral of v du. You're going to use this formula to derive the reduction formula. So it means you need to have u, and you also need to have dv. So you're going to break this part, sine raised by n, then we have x dx. So it will be the same as the sine, then we have n minus 1 x, and we have sine x, we have dx. So these two, this function and this function is just the same, because if you have the same base, you add the power. So you have n minus 1 plus 1, here the power is 1, so you just remain with n. So you have just broke into 2, so we have the same. So we can let this part to be u, then this part to be dv. So we have u as a sine n minus 1 x. So it means you need to find du. You need to find du. So at this point, now we need to find du dx, where we know that we can use the function of a function. This one is the same as du dy times dy dx. So here we can let y to be the sine of x. So if y is sine x, then it means dy dx, we have cos x. Dy dx is cos x. After substituting y as sine x, it means u, sine x is y, so u is y raised by n minus 1. It means you can find du dy normal differentiation, so it will be n minus 1, then y, the power reduces by 1, sorry, power reduces by 1, so n minus 1 minus 1, we have n minus 2, but we know what is y is sine x. So now du dx, it will be du dy, which is n minus 1, then y is sine x raised by n minus 2, then dy dx is cos x. So it means you can have du as the subject. You can make du the subject, so it will be this function times dx. So we are saying our du is n minus 1 sine x raised by n minus 2 cos x. Then our dv is we have said dv is sine x. It means to get v, we integrate dv. So the integral of sine x, it is negative cos x, because we know cos gives you negative sine x. So if it is negative cos x, so negative sine x gives you sine x. So our v is negative cos x. Now we come and apply the formula now. uv, we have our u, then our v is here. From the equation, our u is sine inverse of n minus 1, sine n minus 1 x. So we have in is equals to u sine n minus 1 x, then v is negative cos x minus the integral of now vu du, sorry. So our v is this one, negative cos x, then our u we gotten as du, sorry, our du is this part. So we have n minus 1 sine n minus 2 cos x, then you have dx, and our integral, we are doing the integral from 0 to pi radiant over 2, so it means it also applies to this part, pi radiant over 2. So you're going to realize that when you substitute this integral, this part will become 0, since we have sine x, then you have cos x, substitute 0 and pi radiant over 2, it will simplify to 0. So now you have in is equal to negative, you'll get cos, so you have 0 to pi over 2 becomes positive cos x, and we have cos x and cos x to become cos squared x, then you remain with n minus 1, then the sine of n minus 2 x, like that, dx. So at this point, so you have in is equals to, this one is a constant, so it comes outside, n minus 1. Now the integral 0 to pi radiant over 2 cos squared x, then you have multiplied by sine n minus 2 dx. So using the trigonometric identity, we know that cos squared x equals to 1 minus sine squared x. So you substitute, so you'll have n minus 1 integral, this one is the same as 1 minus sine squared x, and you have sine n minus 2 dx. So if you expand, you're going to get this time this, we have sine n minus 2 x, here you have x. Then when you multiply these two, so you'll have minus power 2, then n minus 2, add the powers, we just remain with n, then x dx. The integral is from 0 to pi radiant over 2, and you have in. So from the initial question, this was in sine nx, the integral from 0 to pi radiant, this was in. So if it is n minus 2, so this part will be in minus 2, and you have minus, now this one will be in, that. So you can expand and simplify the in's, or up to there you still have your answer. So you'll have in, this is in multiplied by this is negative, then moves to the other side, becomes plus n minus 1 in, then it equals to n minus 1 in minus 2. This is minus 1 in, and this is positive 1 in, this one cancels, we remain with n in is equals to n minus 1 in minus 2 as the formula.